We begin in the world that has always fired our imaginations, the planet right next door, Mars. Of all the planets where we've looked for life, it's the one we've studied most. The scientist who may get the first look at Martians, if they're found, is Steve Squyres, principal investigator for NASA's Mars rovers.
Mars has always had, among all the planets, I think, a special fascination for humans. For a very long time, we've known enough about Mars to know that it is probably the most Earth-like.
It may be the most like Earth, with an atmosphere and seasons, but we humans would perish quickly on Mars. Its air is thin, 40 times thinner than the air at the top of Mount Everest. And it sits in a bad neighborhood of our solar system, near an asteroid belt. Its atmosphere is too flimsy to protect it. Asteroids continually bombard its surface. Violent winds can whip Mars's sandy soil into storms that consume the entire planet for weeks and spawn tornadoes 8 kilometers high. Midday temperatures at the equator of 1 degree Celsius fall to -70 at night. David Grinspoon is a curator of astrobiology at the Denver Museum of Nature and Science. As he sees it, Mars would be warmer if it wasn't a planetary runt.
When I grab coffee on a cold morning, I know that a small espresso is going to cool off quickly, whereas a larger coffee is going to stay warm much longer. Large objects stay warm longer because their interiors are shielded from the outside where the cooling occurs. And planets are exactly the same way. A small planet will cool off early in its history. A larger planet like Earth will stay warm for billions of years, which makes it a better place probably to look for life.
Despite Mars's drawbacks, it has always fascinated scientists because its terrain seemed to give evidence that it might support life. Its dynamic landscape of mountains, volcanoes, and deep ravines is not unlike our Earth. To early astronomers, these features look like oceans and rivers, and even a system of canals, supposedly not just supporting life, but actually produced by it.
Percival Lowell in the United States observed these things and inferred that, in fact, these things were so straight and so regular in geometry that they had to have been the product of intelligent life. Okay? Well, he was right. The problem was the life was at the wrong end of the telescope. In viewing this thing visually through a telescope eyepiece, the human eye-brain combination started to connect things that weren't really there.
Lowell was not alone. Some scientists were shocked when the probe Viking 1 beamed back this image. Is that a human face? Perhaps produced by Martians in their own likeness? Until recently, we've never really known where to look in our solar system for extraterrestrial life. But we've always known what the aliens would be like once we found them.
Consciousness. I was on a pickle.
Usually, there is more than a hint of the Earthling in our aliens. Hostile or lovable, they tend to resemble mutant images of ourselves. As a senior astronomer at the Search for Extraterrestrial Intelligence Institute in California, Seth Shostak has spent his career listening for the radio waves of a distant alien society.
There's no reason to assume that they're going to look like us or even think like us or behave like us or have language. You know, you just have to look at the variety of life on Earth and you see that, you know, nature can come up with lots of different forms.
But if there is life on Mars, how could it survive in such extreme conditions? Since the 1960s, scientists have sent dozens of probes to the Red Planet. The first pictures of the barren landscape quickly dashed any hope of finding intelligent beings. But what scientists did see startled them. Though there's no evidence of Martian-made canals, there are signs that Mars actually may have had water. Some think the angry red planet might once have been blue.
You just have to look back a couple of billion years, 3.5 billion, 4 billion years ago. Mars had a thicker atmosphere, had water on its surface clearly. Maybe it developed life. And as it slowly went bad, you know, the life had to adapt.
Life may have adapted, not died off, because some liquid water may still exist underground. But with no surface water, frigid temperatures, and ultra-thin atmosphere, Mars is a planet only one kind of creature could love, an extremophile. Extremophiles thrive in the cruelest of places. To see where they might lurk on Mars, we head to the Valles Marineris, a massive rift in Mars's surface, 20 times wider than the Grand Canyon in places, and almost as deep as Mount Everest is tall. Lakes may have once flooded this valley, and those lakes could have hosted life. As the water dried up, life could have evolved to cope with the harsher environment. We won't know what these extremophiles are like until we find them. But they may resemble creatures that exist in extreme places right here on Earth. An unusual team of biologists, called astrobiologists, study Earth for the kinds of life we may find in outer space. Astrobiologist Rocco Mancinelli is on the hunt for Mars's extremophiles.
If it went beneath the surface, and some of it undoubtedly did, then what happened to it? Well, it formed brine pockets. So what kind of organism can live in a salty brine? A salt-loving organism.
Astrobiologist Chris McKay thinks he knows the kind of salt-loving creatures that might survive on Mars. Creatures much like those he's found in one of the driest, saltiest places on Earth.
The fundamental challenge to life on Mars is, in a sense, the fundamental challenge of life here in Death Valley. It's dryness. That is the hardest thing for life to adapt to.
Thousands of years ago, a salty lake covered Death Valley, just as lakes filled Mars's Mariner Trench.
Move in closer. This is still wet, a little wet.
This appears like a lifeless place, a big, flat, white, empty horizon. But yet, just below the surface, we find layers of algae and bacteria growing. They're living in an environment that in many ways is fundamentally different from the environment that we sense on the surface. Here you're in a place which looks lifeless, looks dead, and yet you dig down and hidden underneath, there it is.
Beneath the salt is a layer of hardy green algae that survive on the water and light that trickle through. The algae in turn feeds salt-loving microorganisms.
Here in deserts on Earth, dried, salty lake beds, we're going to find them on Mars as well.
Salty deserts are not the only places life might be hiding on the red planet. There are Mars's tremendous volcanoes, some of them 6 times larger than those on Earth. Astrobiologist Penny Boston studies the caves, called lava tubes, left over after volcanic lava has dissipated. Not long ago, we assumed caves like these were devoid of life. They get no sunlight, and no sunlight means no photosynthesis. But in lava tubes outside Albuquerque, New Mexico, Boston has found evidence of extreme life.
Because we know Mars has many, many lava tubes. And so here we have the opportunity to see how these formed and also to look at the life that inhabits them.
The extremophiles Boston has found appear to be thriving. They get their energy by feeding on the minerals in the cave wall.
So here we're up close to the wall, and you can see these white patches here growing against the black basalt. And each one of these is like a major city for these little guys. They're all nestled in these little pockets in the basalt. And so these guys are permanently adapted to these freezing temperatures. They never see any light, and they get what they can find in the environment.
Are there creatures like these in the caves below Mars's volcano fields? Boston thinks so.
We are going to find life, and I just hope that I live a long and healthy life so that I can still be around to see that.
We may already have had our first glimpse of Martians, not from our visit to their planet, but from their visit to ours. 16 million years ago, an asteroid slammed into Mars and propelled a 2-kilogram rock into space. Amazingly, that rock sailed to Earth and came to rest in Antarctica. Inside, NASA scientist David McKay and Everett Gibson were amazed to spot the outlines of fossils. Water has carved small tunnels in the rock. And in these tunnels, McKay and Gibson found what they believed to be evidence of bacterial life.
These are little microbes, and they're dead, and they're fossils, or in some cases, we don't even see the forms. We see the footprints or the evidence that they were there.
Life from Mars? Maybe. The hunt is only just beginning. NASA plans to send a rover called Phoenix to Mars. It will study the planet's ice cap and probe 3 feet beneath the surface. NASA even has a plan to send human visitors. They may not meet the little green men of our imaginations, but they could encounter life in some form. What will it look like? It is likely to be a subterranean dweller with an ability to survive on little water. Perhaps an organism with a taste for minerals, like the creatures in the lava tubes of New Mexico. Even the smallest find would have enormous implications. Proof that life is not unique to Earth, but exists just next door.